What if I told you that time travel isn't just science fiction anymore? Right now, as you watch this video, scientists around the world are seriously exploring 7 legitimate ways we might actually bend time itself. And the most shocking part, some of these methods are already happening in laboratories today. Before we dive into these mind-bending possibilities, here's something that'll make you question everything you thought you knew about time. Every single day, you're already time traveling. GPS satellites orbiting our planet experience time slightly faster than we do on Earth's surface due to gravitational effects. Without accounting for this tiny time difference, your GPS would be off by miles within hours. Time isn't the constant river we imagine it to be, and that realization opens doors to possibilities that sound like pure magic. Let's start with the most accessible form of time travel that's happening right now. Einstein's theory of relativity tells us that time moves differently, depending on how fast you're moving and how strong the gravitational field around you is. This isn't theoretical anymore. Astronauts on the International Space Station age microseconds slower than people on Earth during their missions. While these differences seem insignificant, they prove that time dilation is real and measurable. The fascinating psychological aspect here is how this challenges our fundamental perception of time as universal. Our brains evolved to experience time as constant because that's how it feels at human speeds and Earth's gravity. But physics reveals that our intuitive understanding is completely wrong. This creates a cognitive dissonance that both excites and unsettles us when we truly grasp the implications. Method 2 takes us to the extreme edges of space where massive objects create gravitational time dilation. Near a black hole, time slows down dramatically compared to regions with weaker gravity. Spend a year near the event horizon of a supermassive black hole, and centuries could pass on Earth. This isn't speculation, it's mathematical certainty based on Einstein's equations that have been tested countless times. What's psychologically intriguing is how this type of time travel challenges our human need for shared experiences. We're social creatures who find meaning in synchronized moments with others. The idea of returning to Earth to find everyone you knew has aged decades while you've aged months taps into our deepest fears about isolation and missed connections. The third method involves traveling at speeds approaching the speed of light. As you accelerate toward light speed, time slows down relative to stationary observers. At 99% light speed, time would crawl to roughly 1/7 its normal rate. A journey that takes you 1 year would mean 7 years pass on Earth. This concept reveals something profound about human psychology and our relationship with progress. We're naturally drawn to the idea of leaping forward in time to see humanity's achievements, yet we're simultaneously terrified of missing out on the journey itself. It's the ultimate expression of our desire for instant gratification battling against our need for gradual, shared progress. Method 4 enters truly exotic territory with closed time-like curves. These are theoretical paths through spacetime that loop back to their own past. While we haven't found natural examples, general relativity doesn't forbid their existence. If such curves exist, they could theoretically allow travel to your own past. The psychological implications here are staggering. Our entire sense of personal identity depends on linear causality, where our actions have consequences that unfold in sequence. The possibility of closed time-like curves forces us to confront paradoxes that our minds aren't equipped to handle comfortably. Our fifth method involves cosmic strings, theoretical one-dimensional objects left over from the universe's early moments. If 2 cosmic strings moved past each other at high speeds, they could create a region where time loops back on itself. While cosmic strings remain hypothetical, they're mathematically consistent with our understanding of physics. Method 6 explores quantum mechanics and the many worlds interpretation. Some physicists propose that quantum tunneling could theoretically allow information or particles to move backward in time. While this doesn't enable human time travel in any practical sense, it suggests that the fundamental laws of physics might permit temporal anomalies we haven't discovered yet. The psychological fascination with quantum time travel stems from our desire to believe that reality is more flexible than it appears. We're drawn to ideas that suggest the universe might have hidden escape hatches from the constraints of linear time. Finally, Method 7 involves manipulating space itself through negative energy density. Theoretical constructs like Alcubierre drives could compress space in front of a traveler and expand it behind them, potentially allowing faster-than-light travel without violating relativity. While this requires exotic matter we can't currently produce, it remains mathematically viable. What makes these 7 methods so captivating isn't just their scientific validity, it's how they reflect our deepest psychological needs. We want control over time because time controls everything we value, our relationships, our achievements, our very existence. The truth is, while these methods are scientifically sound, most remain far beyond our current technological capabilities. But understanding them changes how we think about time, reality, and our place in the universe. They remind us that the universe is far stranger and more malleable than our everyday experience suggests. Which of these time travel methods fascinated you most? Let me know in the comments below, and don't forget to subscribe for more mind-expanding content that bridges the gap between cutting-edge science and human psychology.